A single agent handles everything, but it can't guarantee execution order. When step 2 depends on step 1's output, that unpredictability becomes the real problem. And the sequential pattern fixes this by hardwiring the pipeline. And you're about to see exactly how. Let's understand using a very simple problem. A trip request comes to the orchestrator. Unlike a single agent, this one doesn't decide the order. It enforces it. Every single time, no variation. Here is the thing, the orchestrator isn't even an LM. It's a workflow primitive that just walks through sub-agents in the particular given order. The food finder always first, the transport agent always second. That's a determinism. And that's the whole point. Without knowing what restaurant we are going to visit, we cannot plan our transport. And that's the whole idea of a sequential. So food finder goes out and search for restaurant, matching your criteria. Now, here is a critical detail. It writes the output to the session state using an output key. That's how the data gets to the next stage. The transport agent picks up the original request plus the food result from the session state. It's the instruction that template variable, in this case food results, and the framework swap that placeholder with the real data before LLM ever sees that. The orchestrator assembles a final trip plan. Once both specialists are done, predictable, traceable, reliable, but you can't skip steps or reorder at the runtime. And that's the trade-off. So what do you get? In a simple words, deterministic execution. Same input, same path every time. Full observability. You can trace exactly which stage it runs, what it wrote, where it broke, and focus prompts. Each agent gets a tight, narrow instruction instead of an overloaded mega prompt. There are many good examples we can think of, such as like loan applications, governmental processes. They all do deserve sequential execution. However, there are many use cases where a simple agent could be sufficient, but sequential agent does provide certain guarantee on top of the single agent. Let's see that in practical. So here I got Visual Studio Code and I'm going to execute a simple example. The server is already running. So this is our sequential agent server. It's got a food finder and a transport and handled by the orchestrator. And the client is going to call the code for this particular example available on GitHub. You can always find there and try yourself. So I'm just running a client and it's going through. Well, that's finished. So we asked based on what we want to eat. It identified the food recommendation, and based on that, it has just come back with some transport plan. By the way, this is just to demonstrate a pattern. So it's not a full-featured example that someone can use straight into that transport or traveling website. However, this is the very good stepping stone to understand the pattern and then build on top of it. The current example uses the OLAMA, which is a very bare minimum LLM, just to demonstrate and understand for the learning or academic purposes. But here is the cost. The pipeline runs every stage, every time. Even if the step isn't need for a particular input, there is no branching. It's A, B, C, not X, then do Y, etc. In that kind of routine, you need a coordinator, and the latency adds up. Total time is a sum of all stages with no overlaps. If your substrate are independent and speed matters, maybe the parallel is a better fit. That's a sequential pattern in a nutshell. Deterministic, observable, reliable, and it costs you flexibility and speed. Next up, we'll see parallel agents where you can trade the strict order for concurrent execution on independent subtask. Thank you.